5.3?
5.4.
5.4. Oh yeah, I just opened it. Very good. So let's take a look. Let's start with 2. Oh, I see. So can you tell me your problem, or?
Yeah, it's parentheses 4 x to the 4th minus 1 over 4 x to the 3rd plus 1 over 5 x minus 9.
Good. So it's the same.
Yeah.
It's the same with what we've been doing. So this will be 4x to the 5th over 5 minus 1/4 x to the 4 over 4 plus 1/5, I meant, x squared over 2 minus 9x and plus a constant c. And I have to clean it up a little bit. So 4/5 x to the 5th minus 1 over 16 x to the 4th plus 1 over 10 x squared minus 9x and plus c. Is this okay?
Yes. I'm almost done right now.
Any questions?
No, I'm good.
Then you said
Yeah.
4.
Yeah. Oh, and it's 7 x to the 3rd minus 3 root x, and no, everything's over x.
Dx.
Yep.
Because the denominator is just one term, I will definitely separate the two fractions. So I have the integral from 7x squared, because 7x cubed over x is 7x squared, minus 3. And now x to 1/2 in the numerator, there's a side note, x to 1/2 over x, 1/2 minus 1 will be negative 1/2.
Okay.
So I have x to negative 1/2 dx. And now it's 7x to the 3rd over 3 minus 3. I have to increase the numerator, the power of the numerator by 1. So negative 1/2 plus 1 will be 1/2. I have to divide by exactly the same number plus a constant c. And that's it, but I have to clean it up a little bit. Let's say 7/3 x cubed. I have to flip this. Minus 6 the square root of x plus c.
Cool.
Any questions?
No, that one was good.
Okay.
And then number 6.
Let's
It's 5 parentheses 1 plus tan squared parentheses a. And just dA.
I think it's alpha, just be careful.
Oh, sorry.
It doesn't matter, but when you put it in, it will consider, if you put a instead of alpha, it will consider it wrong. But you're right, it's the same thing. If you make that mistake on a test, you'll get full credit. I don't care if it's A or Z or T or V, right? The answer will be the same. This is a constant that has to go outside. It's in the way. And then I have 1 plus tangent squared alpha d alpha. So then this is 5. What function prime is 1? Alpha plus 1 function prime is tangent squared, and I don't have that. So obviously at this point I realize that I'm on the wrong path, but I remember that this is an identity. It equals secant squared alpha. So this is one identity to remember. Secant squared alpha equals 1 plus tangent squared alpha, because I can't continue. And I said, okay, let me go back and see what's wrong. So 1 plus tangent squared is replaced by secant squared alpha d alpha. And now I know the answer. It's 5 tangent alpha.
Cool. Oh wait, could you just scoot it up just a tad for me? Okay. Perfect. Could we do number 12?
Yes, which section?
Same section.
Yes, I'm ready.
So it's the integral from 0 to pi over 4. 4 plus 9 cosine squared theta over cosine squared theta. And then d theta.
Perfect. Nice problem. Again, I see the denominator is just one term. I'm going to try and simplify it, separating it into two fractions. Before I do that, I have to stop. I have to look between 0 and pi over 4 if this function is continuous. Yes, between 0 and pi over 4 cosine is not 0. So the function is continuous. So now I have the integral from 0 to pi over 4. 4 over cosine squared is 4 secant squared theta. Plus 9 cosine squared over cosine squared, just 9. So by a simple algebraic manipulation, separating this fraction into two fractions, I simplified it tremendously. So now I have 4 outside. The integral from secant squared, which function prime is secant squared, so it's tangent, plus which function prime is 9, so it's 9 theta, from 0 to pi over 4. Let's stop and see if you have any questions here.
Where did you get the secant squared?
1 over cosine squared. 1 over cosine squared is secant squared. I don't know how to integrate 1 over cosine squared, but changing it into secant squared will solve the problem. Is that okay so far?
Yep.
Perfect. So luckily when I plug in 0, this is 0, this is 0. So I only have to plug in pi over 4. When I plug in pi over 4, that's nice, it's 1. 1 times 4 is 4. Plus 9 times pi over 4. So you can write it as like this, or you can write it 16 plus 9 pi over 4, or 9 pi plus 16 over 4, whatever. All of them are fine. I mean, I don't know. Weber's sign is sometimes disagreeing with me, but they are all the same answer.
Perfect.
How many of your professors say, let's do your homework, let's do anything? How many?
Literally none. It's crazy.
So I am it.
Yeah, literally.
Good. I'm happy. I'll do anything to help my students.
Could we do 18?
Yes, same section.
It's like a word problem.
Okay. Very good. So I read it and you give me your numbers, okay?
Yeah.
So a bacterial population is?
Mine's 3,000.
At t equals 0. Before I even look at the problem, I know that I'm given a point or an ordered pair right away.
Okay.
And its rate of growth is 1,000 times 3 to t, What do you think this?
Mine's 4.
Oh, it's 4? Oh, sorry. 4 raised to t. Okay, bacteria per hour. Bacteria per hour. What is this? So I have two pieces of information. One that says rate, and the other one that says bacteria per hour. These two should tell me exactly what this is. What do you think? It's okay if you're wrong, don't worry about it.
Wait, could you repeat that real quick, what you said?
Yes. So I read the problem. Let's read it together. A bacteria population is 3,000 at time t equals 0, and its rate of growth is 1,000 times 3 raised to t bacteria per hour. This piece of information together with this piece of information, or just one or the other, should tell me exactly what I should write here.
Would that be, is it something over 60?
No, this is the
No.
measurement unit. So what do we measure in blah per hour? Miles per hour, bacteria per hour, miles, cubic feet per minute.
Would it be 3,000 over 60?
So first I have to identify what this is. Obviously it's a function, right?
Yeah.
Okay, so what is it if it's a rate? And if it's measured in bacteria per hour, what could it be?
Would it be,
It must be the derivative.
Oh, I thought you were asking. I was way off. Okay.
That's okay. Maybe
Okay.
I didn't explain it clearly. So I need to put something here that represents this function, and it's measured in bacteria per hour, and it's a rate of growth. So it must be, because this is crucial. This notation is crucial for what happens next, what I need to do next. And then I read on, what is the population after 1 hour? So obviously, I'm asked to find this. If this is the rate, then they want the population at 1.
Yes.
We do have the population at 0.
Yep.
Good.
3,000.
So what should I do?
You should, let's see.
I can determine this before I have f of t. And how do I determine f of t?
That you would use the antiderivative on that, right?
Exactly.
Okay.
So this is 1,000 times 4 raised to t over natural log t plus a constant c. This is what I have so far. So that when I differentiate this, I get the derivative. Oops. So when I differentiate this, I have 1,000. I differentiate 4 to t, which is 4 raised to t times natural log. I meant 4. I said 4, but I wrote t. Sorry. Divided by natural log 4, and that's why these two go away. And that's how we get 4 raised to t.
Okay.
Okay, so now, why is this information given to us?
Because we need to find C, right?
Exactly. So when I plug in 0 for t, the answer is 3,000. So 4 to 0 is 1. So this side is 1,000 divided by natural log 4 plus a constant c equals 3,000. So then c equals 3,000 minus 1,000 over natural log 4. I have to plug it in the function. So f of t equals 1,000, 4 raised to t over natural log 4, and plus all this. 3,000 minus 1,000 over natural log 4. So I got the exact function, the only function that fulfills the given conditions. It's the only one. And now I'm ready to answer their question. The question is that find f of 1. And now f of 1 is a piece of cake.
Yeah, you just plug it in.
That's it. So f of 1, this is 4,000, but minus 1,000. So 4,000 over natural log 4 minus 1,000 over natural log 4 is 3,000 over natural log 4 plus 3,000. Now, how do they want the answer? Round the answer to the nearest whole number. Okay, fine. So this is how I'm going to plug it in. I'm going to plug it in like this. Or 1 over natural log 4 plus 1, doesn't matter. So 3,000 parentheses 1 plus 1 divided by natural log 4. I got 5164 whole number, 5164. Measurement unit, bacteria. So we have the bacteria after initially at 0. We are given the growth rate, and we're asked now, they can ask me for anything. 5 hours, 10 hours, 15 hours, it doesn't matter. I have the function. But they only want f of 1. Does it make sense?
Yes.
So the keywords are rate of growth and bacteria per hour to indicate that I am given the derivative.
Gotcha.
They are giving us the derivative so we can find the function. And then I can plug in anything you want. Very good.